Now on this part of this section we're going to talk about log equations rather than exponential equations. So there's going to be two ways of approaching log equations. The first one is to get everything together into a single logarithm. So get every log on all the logs together on one side and combine them together into one logarithm, leaving everything else on the other side. Once we can get it down to a single logarithm, then we can convert it into exponential form. And in exponential form, usually that leaves us with something that we can solve for. Now there is one specific thing we'll keep in mind when doing log equations is we generally go ahead and check our solutions. Anything that is a solution that causes a log of a negative number will be excluded since logs don't work for negative numbers. So let's start out with an example. This one goes log base 4 of x plus 3 is equal to 2. Now this one, all the logarithms are together. This is just one logarithm. So what I'm going to change is this thing over into exponential form. So basically the way that we do this was to take and swap around the two parts, drop the logarithm, change this into 4 raised to the second power equals x plus 3. That would now be an exponential form. And now it's fairly close to solve. We have 4 squared, which is 16, equals x plus 3. We can subtract the 3 over, and we'll receive x is equal to 13. Okay, here's another one to look at. 6 plus 2 ln x equals 5. Now the first step here is to isolate the natural log, the ln, on one side of the equation. So first things first, I'm going to subtract the 6 over. We'll get 2 ln of x is equal to negative 1. And then I'll divide both sides by 2. And we're going to get ln of x is equal to negative 1 over 2. I would like to change this over into exponential form. But to do that, let's think about the fact that the ln stands for log base e. So log base e of x is equal to negative 1/2. I can swap these two things around, make that e to the negative 1/2 power equals x. And that solves for x. X is just equal to that, e raised to the negative 1/2 power. Okay, here we have log base 2 of x equals 3 minus log base 2 of x minus 7. The thing to do here is to notice that we do have two logarithms, one on one side, one on the other side. So what we want to do is get all the logs together on one side. The way I'm going to do that is I'm going to add over this log base 2 of x minus 7 and add that over to both sides. So that's going to give me log base 2 of x plus log base 2 of x minus 7 is equal to 3. Okay, and now it becomes possible to take these two logarithms that are added and combine those logs together. The way we can combine the logs together is by the thing we call the product rule for logarithms. That would join this together into log base 2 of x times x minus 7. So the addition combines into the multiplication inside the one logarithm. And that's all equal to 3. And so now let's go ahead and convert this into exponential form. We'll swap around the 3 and the other stuff here. So that's going to change it into 2 raised to the third power equals x times x minus 7. Okay, let's continue to solve it from here. We'll distribute the x. We'll make that 2 to the third is 8 equals x squared minus 7x. Now we've run into a quadratic equation. Let's get everything together on one side. So let's subtract the 8 over. We'll get x squared minus 7x minus 8 is equal to 0. So considering that this is a quadratic formula, we may try to factor it to see if that works. So indeed it does. It factors into x minus 8. X plus 1 is equal to 0. So if we set each of these factors equal to 0 and solve for x, we'd have x equal to 8 and x equal to negative 1. But let's think about these two numbers for just a second. From the very beginning, I did mention something about checking our answers. And x equals 8, it checks out because it's a nice positive number. However, x equals negative 1 is not in the domain of the original equation, since it's a negative number. So when we see these type of solutions here that don't work out in a logarithm because of negative numbers, we actually have a solution that's not part of our answer. So that's not actually a solution. Only this one, x equals 8, is a solution to the equation. Okay, here we have a fairly long example of a logarithmic equation. 3 different logs, and the key thing that we'd like to do is try to combine all these logs together into one logarithm. Now we can do that since we know how to handle addition and subtraction of logarithms. Starting with these 2 logarithms which are added together, we can join those together by the product rule. That would change it into log base 2 of x minus 3 times x. And then that's minus log base 2 of x minus 2 is equal to 2. Now since these are subtracted logarithms, we can join those together with the quotient rule. And quotient rule joins them back together with division. So up on top we'd have x minus 3 over x minus 2 is equal to 2. Now what I'm going to do is convert this into exponential form. Okay, the way we do that is we swap around what's on the inside of the logarithm and that number on the other side. So switch around those two things. We keep the base of 2. It's going to be raised to the 2 power, and that's equal to x minus 3 all over x minus 2. So now we're outside the logarithm. We're now ready to just look at it as a equation without the logarithm involved. This would be a 4, 2 squared, x minus 3 divided by x minus 2. Now the way I'm going to have to solve this one is to start out multiplying both sides by the x minus 2. That way I can get rid of this denominator. Now that changes it into 4, x minus 2 equals x minus 3. Okay, so let's go ahead and distribute the 4 into the parentheses here. We could also distribute the x into the parentheses. So 4x minus 8 equals x squared minus 3x. So another quadratic equation. Let's go ahead and get all the stuff together on one side. So I'm going to subtract over the 4x. I'm going to add over the 8. X squared minus 7x plus 8 is equal to 0. So this is identically what we had seen in the last example. We will factor it. It factors into x minus 8, x plus 1. And each of those factors, when set equal to 0, we solve for x. We get x equal to 8, x equal to minus 1. But like last time, we see the number negative 1 and we check. That's not in the domain of the function or the equation. So this one's not a solution since it's negative. So we will exclude that as part of our answer, and only x equal 8 is a solution to this equation.